So my problem is number 63, and I have MgOH2 plus H2SO4 reacts to MgSO4 plus H2O. And we are given 1 gram of MgOH2 reacting with 0.605 grams of H2SO4. And our question is, what is the mass of MgSO4? So to get to that first question right there, what we're going to do is we're going to start with our first given, which is 1 gram of MgOH2. So let's write that first. And what we need to do is get this into moles. So we're going to do is we're going to put moles on top so that we get it by itself, and then we're going to put our molar mass on the bottom. And our molar mass we get by taking the numbers from the periodic table and adding them. And so what we get from MgOH2 is 58.31, and that's going to be in grams because it's the it's the molar mass, so it's the weight, and it's going to be MgOH2. And on the top we're going to have 1 mole of MgOH2. And so these two are going to cancel each other's out. And what we're going to do is we're going to do 1 gram times 1 from the mole. We're going to take the 1 from the mole, and then we're going to divide it by 58.31. And that's going to give us 0.017, and it's going to be in moles. So moles of MgOH2. And what we're going to do is we're going to take the answer from this equation and we're going to put it down here to find our next amount. So MgOH2. And what we want to find next is the amount in moles of MgSO4. And so what we're going to do is we're going to put 1 mole MgSO4, and then we're going to have 1 mole MgOH2. And what that's going to do is that's going to get this by itself for us because these will cancel out. And we're going to get the same exact thing that we got up here, 0.017 moles, and it's going to be an MgSO4 this time. And the reason that these two are the same is because we're working in a ratio of 1 to 1, because we have 1 magnesium over here, and then we have 1 magnesium over here. So these are going, the moles are going to equal the same thing. And so what we're going to do next is we're going to take this answer that we got here, MgSO4, and we're going to use this for our next equation. So what we're going to do is we're going to get this into grams, and how we're going to do that is we're going to do what we did up here essentially, but we're going to flip it. So we're going to find the molar mass of MgSO4. And how we do that is we get the numbers from the periodic table of Mg and SO4, and we add them up, and that equals 120.38. And it's going to be in grams, again, because it's the weight of something, and it's going to be MgSO4. And what we need to do on the bottom is put it in moles because we want these to cancel out. So it's going to be 1 mole of MgSO4, and these will cancel each other out. And we're going to do the same thing that we've done for the last two. We're going to do 0.017 times 120.30, and it's going to be over 1, and that's going to give us 2.05. And it's going to be in grams because that's what we got by itself. Grams of MgSO4. And so what this essentially tells us is that for 1 gram of MgOH2, we will make 2.05 grams of MgSO4. So we're just going to put this in the corner so that we remember.
There's totally this thing that's scouting out that car. Like you want the drum around stop and not directly on right there.
So that we remember what we got in that first half of the equation. Okay, so for the next half of this problem, we're going to, since last time we started with our given of 1 gram MgOH2, we're going to start with our second given of 0.605 grams of H2SO4. And so what we're going to do is write 0.605 grams H2SO4. And what we want to do is we want to get this into moles again. So we're going to have to put the mole on the top to get it by itself. And it'll be 1 mole H2SO4. And then on the bottom, we're going to put our molar mass. We get that by getting the numbers off the periodic table, adding them together. Problem because the first time, for the first half of the equation, we used the 1 gram of MgOH2. We're now going to use 0.605 grams of H2SO4. So we put it into 0.605 grams H2SO4, and we want to get it into mole form. So we're going to put the mole on the top, and it's just going to be 1 mole H2SO4, and on the bottom we're going to have our molar mass. And we get our molar mass by getting the numbers off of the periodic table, adding them together, and that comes to 98.07. And it's going to be in grams again of H2SO4. And these are both in grams, so they're going to cancel out. And we're going to do 0.605 times 1, and then divided by 98.07, and that's going to give us 0.01 moles. Moles of H2SO4. And so now that we have this in moles, we're going to get the moles for the H2, or Mg, sorry, we're going to get the mole form of MgSO4 now, because that's the one that we don't have. So we'll put 0.1 mole H2SO4. And again, we're going to have moles on top and bottom because we're still trying to find the mole version. So we're going to do 1 mole of MgSO4 because that's the one we're trying to get. So it's going to be MgSO4 over 1 mole H2SO4. And these two are the same, so they're going to go ahead and cancel them out. And it's going to be 0.01 mole times 1 over 1. So we're going to get 0.01 MgSO4. And you'll notice that these are the same like they were in the first half of the equation, because we have a 1-to-1 ratio again. And the 1-to-1 ratio this time is in the SO4 and SO4. And so after this, we're going to use what we got here again, and we're going to do 0.01 MgSO4. And we're going to use the molar mass of MgSO4 like we've done the last couple of times. And so we add them all together, and that's going to be 120.38 grams. So we're going to have 0.01 moles of MgSO4, and we're trying to find the gram form. Sorry, we're trying to find the gram form now. So we have our molar mass on the top, and then we're going to put our mole again on the bottom, because we want these to cancel each other out. SO4. These will cancel each other out, And so we'll end up doing 0.01 times 120 essentially, and that's going to give us 0.74 grams, and it's going to be of Mg.
Alright, that's fine. And
SO4. So we know that 0.74 is smaller than the number that we got in the first part of the equation, which is 2.05 grams. And so since this number is smaller, this is going to be our limiting reagent. So we know that our limiting reagent is going to be H